Hello everyone. So now that we're getting more comfortable with inheritance and polymorphism, I want to talk about multiple inheritance. And what that means is sharing code from multiple classes in one class, so extending more than one class, instead of having this direct hierarchy from one to the next. And to motivate this, I'm going to go back to our lab 3 and look at this little code snippet here. So I've written some code to draw a bunch of random circles. So they have a random center between 0 and 1 in each coordinate, and they have a random radius between 0 and a third. And they're all going to be drawn with blue and thickness 0.01 for now. Okay, well, I'm going to store them in an array because there's something I want to do in a second, but let's just run this and see what it looks like. Okay, so it gives me this picture. If I run it again, it will give me a different picture. Okay, so these are random. So let's say I want to know what is the minimum circle. So what I could do is actually implement a static method in the circle class. So it's not going to be tied to a particular circle object. It'll actually belong to the class. And its job will be to find the minimum circle and return it. So I can say public static circle get min circle, and I'll pass it an array of circles. Okay. So, and I guess I can make a decision about what do I want minimum to be. Well, I might as well do the radius of the circle since the area is also proportional to the radius. So if I find a circle with the minimum radius, I'll also be finding a circle with the minimum area. So let me go ahead and do that. So so the biggest the radius can be in this example I know is a third. I'll put a number bigger than that. So I'll say double min radius equals 100. So that's way bigger than the biggest radius I know I can have. So I'll say for int I equals 0, I is less than circles dot length I plus plus. And I'll say if the circle at index I has a radius, so I called it r in this code, less than the min radius, then I will update both the min radius and what the min circle is. So the min circle should point to the circles at index I. Okay. And then when I'm finished, I'll return the min circle. So what's it complaining about here? Min circle may not have been initialized. Okay. So there's actually, yeah, I can say this and it'll be okay. It'll stop with that compile time error. There's actually a slightly more elegant way to write this. So what I'll say is if the length of the circles is greater than 0, I don't have to do this ugliness where I actually try to have some prior knowledge about what the minimum radius will be. I'll actually say, let me start off with the minimum circle being the first circle. So I'll make it the min radius be circles at 0 dot radius, and I'll make the min circle be the circles at index 0. And now I can loop starting at 1, and I'll return this at the end. Okay. So that's another way to do it. This way is a little more robust. I don't have to know ahead of time what a bound is on the radii. I can just say, let me guess that the first one's the minimum one. I just have to make sure I'm not going to go out of bounds if somebody happens to pass me an empty array. Okay, fair enough. So what I'll do is I'll run this method that returns the minimum circle object, and I will change the circle. I will change the color of that circle. So let's say circle min circle is, so I'll call the static method circle dot get min circle circles, and I'll say min circle dot set color dot red. So I'll draw the smallest circle using red. So I'll draw it again, min circle dot draw. Okay, so let's see what that looks like. Okay, so here's an example. That looks right? That's the minimum circle. Here's an example. That's definitely the smallest. Well, it looks like it might be timed with that. Okay, so that's working. But here's the thing. So I've gone through this effort to write some code, which, I mean, I'm going to write this code over and over again, this get minimum thing. You know, I might go to the COVID lab and say, I actually want to know what is the minimum X location of one of these dots, or what is the minimum Y location of one of these dots. So then I'm going to have to rewrite that code, right? So it seems like I should probably try to encapsulate this code somewhere else so I can share it among these classes. So here's what I'll do. I'm going to make a class, so I'll stick to the shapes for now, but I'll make a class called numberable. Okay? So what numberable is going to be is it's going to be some object that has to return a number. So it has to be able to return a number for every object that I can sort. So in the circle, it was the radius, but in the person, like I said, it could be the x coordinate or the y coordinate. I could even make it the x or the y coordinate in the circle class as well. But as far as the parent class numberable would be concerned, all I have to do is be able to return a number. So I'll say public double get num. And by default, this will return 0. But we should extend this and override it and try to implement our own version of get number for circles. Okay. So let's do that. And actually, yeah, let me now let me move the code that takes the min into numberable instead. So I will no longer have. So I'll just say get min numberable, or maybe just get min, and these will be numberable objects. And so I'll just change all these types to numberable. And I'll replace these with the name objects. And now it's not necessarily the radius. I'm going to have to use whatever the method is for getting the num. So we'll just say get num here, and get num, and get num. And I guess I should also change this to min object, min value. Okay, so all I'm doing is I'm refactoring this code so that it's going to work on a general thing that is able to be numbered with this function. Okay. All right. So this does the same thing, except I need to change the return type to numberable also. Okay. All right, cool. So let me go back to circle, and let me try to, so circle extends shape, but now I'm also going to have it extend numberable. We got some major problems here. So it doesn't like that. Did I get the syntax wrong? Do I have to say extend shape extends numberable? Well, that doesn't work either. Huh. So we're in a bit of a pickle. So why is this happening? So Java does not allow this, actually. You can only extend one class. And here's the reason why. So here's the problem that pops up. So we're trying to make this circle class, right? And we want it to inherit both from numberable and from shape. But let's say hypothetically that numberable and shape each happen to inherit from some other class. I'll call it parent. Let's say that this parent has a method get ID or something, okay? And that numberable overrides that method. And shape also overrides that method. So there's a problem. If circle inherits from both of these, both shape and number, and shape and number happen to override the same method, but in different ways, it's not clear. So if I don't then override the method getID in circle, it's not clear which getID I should use. Should I use the getID from numberable? Should I use the getID from shape? I don't know. So this won't always happen, but it will happen if these two things override the same method from a parent class that they both share. So this is the simplest way it can occur, and this is called the diamond problem. So you see how these make a diamond. I split off here, I override the same thing, and then if I try to converge again, it's like, well, which one do I use? Now you could just say, well, maybe I'll specify which one I'm going to use, but it becomes a big mess. So Java just decided to disallow multiple inheritance, period. I actually should note that every class inherits from the object class. So there are methods that every class has, which you already know, right? I mean, the object has a default constructor already. It also has a default two-string method. In fact, I can show you what the two-string method looks like right now. So if I have this override annotation and I say, click this green dot, I can go to the two-string method in object. Oh, I wanted to go to its implementation. Hang on. This is cool though. Okay, well, it's not letting me look at it now. Anyway, what I was going to show you is there is a two-string method for the object class. And numberable could certainly and will override two-string probably, and so will shape. So if I want to make a two-string method down here, which one should I use by default? And also, what is the meaning of super even? So if I wanted to say super.toString, does super refer to the numberable class or the shape class? So that's a diamond problem. So Java does this a different way. Java says, okay, you can't do multiple inheritance, but you can do something called interfaces. So I can make something called an interface. So let me do that. Instead of making this class called numberable, let me pull this code out for a second. Let me delete this class, and I'm going to say new interface, numberable. Okay. So you see, instead of saying class, you say interface. And you can have static methods in here, but it turns out everything in an interface has to be public. Okay, so this is like a class, but you'll see in a second it's a little different. Also, you're not supposed to implement the methods that aren't static, because they're not really tied to an object. Okay, so let's see what's going on here. So this interface gives kind of a skeleton, or we call them abstract methods, of saying, look, if you're going to be in this class, you better have a method called getNum. And so, every time if I then say, I'm going to get something that's of the numberable class or numberable interface, I'm guaranteed that they've implemented that getNum method, so I can use it like this. Okay. So what I can say is, here's the syntax. Public class circle extends shape, but implements numberable. So that's the keyword you use to say, I want to override, or really, you're not overriding because there was never a definition in the first place. It was empty. But I'm saying, I want to actually give you a definition for this method, and I want it to be tied to the numberable class. Okay. So if I go back to circle here, that's the syntax. So it extends shape, so it's going to inherit from shape, but it's going to implement all the abstract methods in numberable. Okay, now it's giving me an error. Why? It says circle is abstract and does not override abstract method getNum. So I have to add a method. If I do that, so here it is. By default, it says not supported, but I can actually implement it. So this is a different kind of override. I'm overriding an abstract method, something that's really just a placeholder from this interface. So I'll just say return R, so return the radius. That was what we had sorted them by. Okay, so if I go back to the myDrawing class, what I can do is, so this no longer exists, but I can say circle min circle is equal to numberable dot get min, what do I call it? The static method was just get min. Okay, get min circles. And because it's returning a numberable, I have to cast it as a circle. Okay, now this code should work the same way. So let's run it. Okay, so that definitely worked. That's the smallest one. Here, let me do this again. Okay, another very small one. Okay, that one's a little bigger, but still the smallest. Okay, so that's cool. So I didn't really change much of the code. I just moved it into here, and I said, look, if you're going to be able to get a min, you need to be able to turn me into a number. That's at least the way I'm doing it here. So you're going to have to implement this thing. And if you do, then I can pass an array of u along here. So if you implement numberable, then I can cast you as a numberable and call this getNum method. Okay? Now I could also say, well, let me change, instead of the radius, let me return the center x coordinate. So I'll return center.x. Oh, right, that is, I have to use the getX method. Okay. So now if I run it, so I'm just changing my implementation of this getNum. And now I see, okay, this is not the smallest circle, but it's the furthest to the left in terms of its center. Here's another one. Here's another one. So now what we could do is take this numberable class, or interface rather, and actually move it into the COVID lab and use it there. Or we could put it in another package and use it in both. And that's really what we should do. Okay. So tomorrow we're going to do an exercise where we do that. And then we're going to look at another interface called comparable, which is a little more general than this numberable thing that I've made. Comparable says you don't have to come up with a number. You just have to say, given any pair of objects, which one is less than the other. So you've seen this before with compare to with strings, for example. So that's the method that comparable makes you implement, is compare to. Okay, so I will be calling on somebody tomorrow to tell me about inheritance and the diamond problem. And we will do that exercise. See you tomorrow.